For this demonstration, so I'm still sticking with a form that is a cube, but it's hollowed. I'll be using the vertical line, and the shadow direction will be horizontal, parallel to the picture plane. So my vertical edge is that, and this will be my light direction. So simple. So if we apply it here, shadow cast for this one. So we can always imagine, we can always project these things happening in X-ray version. So this is an isometric version of this perspective drawing of this form. And we can always project, of course, the hidden line. So 45 degrees of this shadow casting. So equal to this is this, equal to that somewhere there. Of course, there's another point there. The opening of that is here. So that's my SD or shadow direction. So this entire thing is the shadow cast for this column. Of course, for this edge, project down 45 degrees equal to this. If you're not sure, you can always take your pencil, measure it, and compare. So it's equal to here. For the shadow projection of this point is here. If we're going to project it, so this is going to be the shadow projection of this to there. Take your pencil again. You can always gauge that equal point somewhere there. It's 45 degrees. Where it hits, project up. Where it falls or corresponds to that line, or corresponds to this point, is where this will be projected on. So this is a void. So the shadow casting of this segment onto this plane is this, much more elongated. So it's not yet complete here. So again, we can always imagine where the void is, or where the edges are underneath this. Going here, coming here, do a 45 degree angle. So the edge underneath is where this is, 45 degrees. Therefore, you do a projection of that, and this becomes then the shadow cast of this volume or this piece here. And of course, the rest. Measure with your pencil, 45 degrees. If that's the angle that you want, draw the light direction line. This is the vertical. So the edge casting of this is going to be here. Get that measurement there. You can do the shortcuts already. Let's go to here. Project. If you're not sure with your parallel lines, you can always take your pencil and take a look. Again, the volume here, it's up to here. So the void, the ground of that, do a 45 degree. So it can't be seen there. Where does this edge stop? You can take the measurement of this, which is that. March it to here. It's up to here. So therefore, it's projected here. So this edge behind this is this. And it's projected as such. And where does it stop? So you need that projection again, 45 degrees. It's up to there. Of course, there's a void here. So you need to plot, of course, the edge where that point is, 45 degrees. Project that, 45 degrees. So the shadow cast for this one is this, and then the void somewhere here. Underneath this is the edge. You need to project that instead. So it's somewhere here. Do the outline. So it's up to here. 45 degrees up to here. So the void shadow is here. So that's the void casting of this. So up there. So this is a matter of just getting used to this kind of system to a point where you know the principles of shadow casting, and this will become second nature. That's underneath, going there. there's supposed to be a shadow casting there. So what you can do here now is you can get that information from here. So get that, project it over to there, and you can see that it's going like this. It's a parallel line. That's the void. And so you get this information already with this correct plotting for this type of form. You can now sort of like project this shadow casting type onto the perspective drawing by just doing a similar casting. Example, you could get that information from just projecting the angle of this parallel to this from here to there. So it's that point. Same thing. That angle to this point. For this shadow cast on to the surface, it's too tiny for you to define. For the shadow casting of the volume here, it's going to be thin. So I can get the 45-degree angle here. Do the shadow line. So it's somewhere there. And the light direction is 45 degrees. So it's somewhere there, extended. So if I take a extended version of this and have a 45-degree, it's equal to, so this vertical height is equal to the shadow line. So it's somewhere there. Where they intersect, you can always project it towards vanishing point X, for example, there. And then this one, from this point, let me project this point's shadow direction, which is horizontal to the picture plane or horizon line. Get that same angle, 45 degrees, or you match this to there. So it ends up here. And you project that. For this void shadow, you can eyeball this, or you can construct the vertical line plus the shadow direction, 45 degrees. You can get that. Same way here. Project all the way and get that. So you have this sort of volume. But it's too small of an area for that void shadow, for that light casting. So you can eyeball it based on this. And you can project it going this way. And shadow cast and shade it. So what I've done here is basically just mimic what the result here onto perspective, but it's the same ruling for the shadow castings, vertical shadow line direction, and of course the light direction. So it's pretty much the same. So it's easier than something when the light source is coming from behind the viewer. And so therefore you need to project the inverted sun vanishing point, which is somewhere here down a bit more or off paper, so that the shadow is also foreshortened in the perspective drawing. So this is just one example of how to figure out shadow castings of forms by first doing the isometric drawing shadow casting, and then you can do it here onto the perspective drawing.